Hey everyone, welcome back to my channel. I hope you're enjoying my videos. Please like and subscribe and support my channel. Today I'm very excited to start a new series of videos on Xstate. So Xstate is another state management library for React, but it is one of the more promising ones and one of my personal favorites. So Xstate allows you to configure your state in the form of a mathematical model, mental model, where you can define your app logic in the form of states and transitions. So first let us quickly jump into action and let's install Xstate and also Xstate React. So Xstate is the secret sauce. It is where you define your app logic, and Xstate React is the bindings for Xstate for React. So the way Xstate works is you define a machine, you define a finite state machine, and a finite state machine is nothing but a collection of states and transitions that your logic can have. And your logic can be anything. It can be a button, it can be a huge workflow like a sign up flow where your user can enter an email, choose a password. All of these are multiple steps, and all of these steps can be configured inside your machine. We'll discuss more eventually, but for now let us implement a simple checkbox using Xstate. So we define our state in the form of a configuration of states and transitions. So let's do that. Xstate is already installed. So now I'm going to import machine from Xstate, and I'm going to create a checkbox machine. It is a machine and it has some states. The first state is switched off. So all states, you need to configure all of your states inside an object called states. So there is a switched off state and also a switched on state. And we also need to define the initial state that our machine is going to be in. And the initial state is switched off. Okay. So we have already defined our machine. Now we need to start using the machine. And Xstate React provides us a very handy custom hook called use machine. Makes life very easy. So I need to import use machine from Xstate React, and now I can simply start using my machine. Is there an error here? Oh yeah, from Xstate React. Now I can simply start using my machine. So use machine returns something. We'll get to that. So use machine of checkbox machine. Let's just print what it returns. Value console.log value. Now if I look at the log, there is the first argument is state and the second argument is a function. So let us grab the state and also this function, whatever that is, and let's log state. So state is an object. It has some stuff here. We'll get to all of that eventually, but the important thing here is that state.value here is switched off. So we can use this to configure our checkbox. So I'm going to just put a paragraph here, checkbox, and I'm going to create my checkbox element. Input type equals checkbox, and all checkbox inputs have a prop called checked, and with this we want this to be true only when the state is switched on. So in this case we can simply pass in the state dot value here. If state dot value equals switched on. Okay, so now this is off. So this function here, this function is nothing but a way for us to interact with the machine. So as I said earlier, our machine is a collection of states and also transitions. So finite state machines allow our app logic to be defined in terms of a finite list of states, and our logic can only be in one state at any given point of time. So if it is switched off, it cannot be switched on at the same time. So that is how finite state machines work, as you can only be in one state at any given time. And if you want to go to another state, you can transition from one state to another. And you need to define your transitions on the state that you are in. So when we are in switched off, if we don't have any transitions, the machine cannot change the state. So now let's define a transition for us to move to switched on state. So to define a transition, we need to pass in a key called on, So here we are saying that if you are in the switched off state, and when a transition occurs on the switched off state, and this transition we are going to call it switch on. So I'm going to put it in caps just to differentiate, because everything here is a string. I'm going to use caps for all transitions. So switched, if the switch on transition occurs, then go to target switched off. Switched on. Okay, and now this function, we can call this function with the transition name to make our change into the switched on state. So this function is for that purpose. And this function is generally called send, because we are sending some information to the machine. So we are requesting our machine to transition to another state. So what we'll do here is let's put a button here. A button switch on. And on click, we can send the name of the transition, and in this case it is this one, switch on. Okay, I need to close this tag. Okay, now we are in switched off state. Let us click on the button. Let's reload the page. Switch on. There we go. It works. So now I want to toggle it back. In this case, again, let's create another button. Switch off. And in this case, I'll send switch off. Okay, I'm going to reload the page. So switch on is, checking the checkbox. Switch off doesn't do anything, because first of all, the transition is not even defined. So we need to define the transition on the switched on state, because that is where the current app logic is at. That is the state in which we are at right now. Okay, so on switch off, we need to go to switched off. Okay, reload, switch on, switch off. It works. But again, if you're already in the switched on state, even if you send a switched on action, switched on transition, nothing happens, because the transition has not been defined on the switched on state. What we can of course do is because this is a rather simple machine, we can use the same transition name for both states. That is also very much valid. So I can simply put in toggle, on toggle switch, and I'll use the same name, and I'll use a single button. Okay, so toggle switch, and I'm going to send in toggle switch action. So now the same action can be used for both states now. I'll refresh, and right, it works perfectly fine. So let us do a quick recap. So we have created a machine where we have defined our states, switched off and switched on. And we have defined transitions on how we can move from one state to another. And we have also started using that state with our input elements. So of course, the last thing that we can do is, there is no point in having a button to do that. We can simply click on the checkbox itself. So let us put that over here. So instead of on click, we can do on change, and simply click, and simply do toggle switch. Just refresh. Okay. So this is a quick introduction to Xstate. We'll discuss a more complex example now. Now let us build a read more component with Xstate. So we want our component to be able to display some text and slice it if the text is long, and then give a button that when clicked will show the full version of the text. And we want to build all of that using Xstate. So we have already seen how Xstate helps us build logic where you can only be in one state at any given time, and you can navigate between states using transitions. So that is what makes Xstate very special. It is very predictable, and because it is predictable, it also allows you to build tools that help you as developers to visualize your machines. So before we build our read more component, I want to show you a very nice tool, which is the visualizer, which helps you look at your state machine logic before you even start using it in your components. So by default, there is a fetch machine that you can see on the visualizer link. So it's xstate.js.org/viz. So you this machine is a default machine that you can visualize in the visualizer, and you have three tabs here: definition, state, and events. So we'll take a look at that. So this is the machine, and this is how it looks in the visualizer in the UI. So we are starting at the idle state, and fetch is a transition for idle state to the loading state. So because Xstate is based on finite state machines and everything is so predictable, you can make tools like this. You know exactly what transitions map one state to another, and and you can visualize the entire state machine logic like so. So we can now see how the machine will progress from one state to another when we click on this transition. So now it went to the loading state. It has two valid transitions now, resolve and reject. And let us see what happens when you reject. It goes to the failure state, and you can retry and go to the loading state again. And then again, once again, you're at resolve and reject. And this time, if I do resolve, then it goes to the success state. And notice that all states here have a single border, and success has double border. It means that this state is a final state. It does not have any transitions to any other state. This is where the machine ends. So, and this, you can create final states by specifying type final. That's one way of specifying that this is a final state. You can also just simply not have any transitions, but it's helpful if you put type final. It tells the machine that the logic has ended and there is nothing else to do. So now let us look at the events tab. So here you can look at all the transitions that have happened. So fetch happened, then reject, retry, resolve, and then you can look at the current state of the machine. You have value success, and there is also context. So this context is very interesting. So we have only seen how in a machine you can have states and transitions declared with strings, which are pretty much static, but you can also store some inherent data into your machine in the form of context. So unlike React context, this context is pretty much analogous to state. It's a variable where you can put in some values, and when those values change, your components are going to re-render. So this is basically the machine's context, so some storage for the machine. We are going to look at that in this tutorial. The read more machine that we are going to build will have some context as well eventually. So now what we will do is we will build our machine in the visualizer first, and then we'll apply that in the code sandbox. So as I said, we want our machine to be able to have two states. One is the clipped state, where we only show a subset of that, a substring of the original string. And then there is also an unclipped state. So two states. So let us build that. So const read more machine. Initially it starts at clipped. Sorry, this is the ID. Initially starts at clipped. We don't have to worry about ID right now. At this point, we are not going to have context. We are not going to have a failure state as well. Let us remove this. We'll have only two states. The first state is clipped, and the second state is unclipped. So on, we have already seen how you can have the same transition applied for multiple states. We can just have the same string. So in this case, I'm going to put in a toggle clip, and when you're in the clipped state and when the toggle clip transition occurs, we want to move to the unclipped state, and the unclipped state does the same thing. On toggle clip, we want to go to the clipped state. Okay, now let us update this, and this is how our machine looks like when it is visualized. So clipped on toggle goes to unclip, toggle again goes back to clipped. Pretty much exactly what we want. So now I'm going to copy this and go to my sandbox and create our read more machine over here. So let us take a look at the code a little bit. So we have a display text component which is responsible for rendering this, and the content is pretty much a hard-coded value, data of 1. We will make it more dynamic eventually in this tutorial itself. So data of 1 is a string which has an actual length of 888 So it has 888 characters, and our logic is this: if the length of the string is more than 200, we are going to slice it. That is the eventual logic. But for now, we are going to slice every string if it is in the clipped state. So now what I need to do is, I don't want to show a substring all the time. I only want to show the substring if the state is in the clipped state. So first let us start using a machine. So const state send equals use machine of read more machine. So we need to import use machine first from Xstate React. Okay, so now what we can do now is, if state dot value equals clipped, then we slice it. Otherwise, we show the full string. Okay, now we also have a read more button here, and we'll make the logic simple. So on click, we want to send a transition to toggle the clip. This is similar to the checkbox logic that we implemented a bit earlier in this video. So we want to send this transition toggle clip. Now I'm going to refresh. So if state.value is clipped, we want to slice it. Otherwise, we want to show the full string. I think it should work. It works. Awesome. So when I click on read more, it shows the full string. So now we have the read more logic implemented, except that the data is hard coded. We don't want to do that. So we will use context to send this data to the machine itself. And we'll also grab data from, so we'll implement a map. We have, so the data object here is an array of 3 strings, and we want to render all the 3 strings. And we're going to do that by simply mapping over the data object. So data dot map for each text, for each content, render the display text with content equals content and key equals content. I'm simply rendering all the strings here. So earlier we only had the hard coded. We were only rendering the first string here. The second string here at index 1. Now we'll render all the text inside our display text component, which has the read more logic implemented. Okay, so instead of grabbing data of 1, we'll grab content from props. Okay, so this one is rendered. So this one has a text length of 121. So this is well below our budget of 200. So this thing here doesn't even require the read more functionality, because it is a very small string. So we'll implement that as well. So when the string is smaller than the cutoff length, then we'll not even have the read more logic. Okay, and the other 2 strings, they work perfectly fine. Let me refresh. Okay, yeah, they both work fine. So now what we'll do is, if the text length is 121, is less than 200, then we'll not even have the read more logic. So to do that, the use machine needs to be aware of the text length, because we are starting off with the clipped state, and we don't even have any state for disabling the read more button. So let us have another state. We are going to call this disabled. So if it is disabled, then we won't even show the read more button. Okay, so if state dot value equals disabled, then we don't show anything. If it is not disabled, then we'll show the button. So as of now, because disable state is not even being used, all three texts are showing the read more logic. So now what we want to do is, we want our machine to be able to look at the content and decide if it has to be in clipped state or disabled state by when it starts. So to do that, we are going to send context. So the second argument can take some extra values, and we want to send context as the content. So we're going to send our content into the machine context. And now what we will do is, in the initial state, we will not hard code it to clipped. Instead, we'll have an intermediate state. And this state, we're going to call it unknown. Okay, I'm going to refresh the page. So yeah, so unknown state doesn't even exist. We need to create that. So this is a very handy feature with Xstate, because all of our states need to be defined statically before they are even used. Because the final state machine logic is so predictable, it's very hard to go wrong. We cannot use any state that is not even defined. So let us define our state. So this state is called unknown. Right now it doesn't do anything. So we still see the read more buttons here because the logic is simple. If value is clipped, then we slice it. And because the state value is unknown, we are still showing the full content. We are also showing the read more because it is not disabled. So we are going to make our unknown state a transient state. And instead of having a transition based on, we will have a transition called always. We'll have a key called always. And what this means is that this state doesn't, this has an implicit immediate transition. And we are going to transition to the state clipped. So now let me refresh the page. So now it started at unknown and it immediately went to clipped. Of course, we don't want that. We want to go to the clipped state only when a condition is satisfied. So this is implemented using guards. So state machines have states, transitions, guards, and also actions. We'll cover actions as well. So guards help us have conditional logic within our state machines. So instead of putting in a string, I'm going to put in an array of. So instead of putting a string, I can describe the next state using target. We have already seen that. So this is the longer version, and this is the shorter version. So I can use the longer syntax. I can also put in an array of the longer syntax version. So I'm going to put in target to disabled, and I want to disable it when a condition is satisfied. So I'm going to put in COND condition, and I'm going to call this condition as text length less than 200. Okay. So when this is true, then it will go to disable state. Otherwise, I'm going to put in another object. I'm going to put in target as clipped. So what the machine does is it tries to go to the first state, and if this returns true, then it goes to the disabled state. Otherwise, it tries the next immediate object in the array, and that keeps going on. The process keeps going on. So now we have to define this condition. The way to do that would be to pass in a second argument to our machine, and this here, this is where we can pass in some extra configuration to our machine, and we need to put in an object called guards inside the second argument object guards, and within this we need to put in the same name. So text length less than 200. So this is the name, and this is a function, and here we need to return something. So this function here can access context. By default, all of the guards and actions can access context. So I'm going to log the context to the screen, and I'll return, for now I'm going to return true. Let me reload. Unable to evaluate guard. Why is that? Text length less than 200. So console.log context. Okay, so let's take a look at the console. There we go. So the context is an object, and it has content as a member. So it has that as a member because we are passing in context here. When we are using the machine, we are specifying the machine, and we are also sending the content inside context. And when the machine starts, it has the context and the content inside the context. So now we can use this here and return true or false based on the context length. So what we can do now is return context dot content dot length is greater than is less than 200. So if it is less than 200, it will go to disabled state. So let me refresh now. Okay, so the first one has length 121, so it went to the disabled state. We can actually start logging our state to see what it is. Okay, I'm going to refresh. Okay, so disable definitely happened twice. So it is rendering multiple times. This is something within use machine. It can render only once, but it is rendering twice. I'm not sure why, but it's probably some internal state update inside the component. So the first two disables are for the first text inside data. The second two are in the clip state by default. And now I can click on read more and it will go to the unclipped state. Okay. So we have also seen now guards, how guards work. We can use guards to use a transition state and decide what initial state we want to have in the machine. So to do a quick recap, we have created our machine to have a transient state called unknown, which will try to go to the disabled state if the text length is less than 200. Otherwise, it will go to the clip state. And the clip state and unclipped state both have toggle clip transitions. There's also a disabled state where nothing happens, and this is the state where the unknown transient state will go to if the text length is less than 200. And we're using the machine by passing in our content as the context value. Okay, so now the last thing that I want to cover in this tutorial is actions. Actions are basically functions that you can run when you move from one state to another. They are basically side effects that you can execute. So you can do things like making an API call, logging something to the screen, so on and so forth. You can also modify values inside context. So let us start with a very simple action. So what I want to do is, when I'm in the disabled state, when I enter a disabled state, I simply want to log something to the screen. So what I can do now is I can have an entry action, and I'm going to call log disabled. Okay, so this action hasn't been defined. So similar to how we define guards, we'll define our actions here. So I'm going to create an object called actions, and then log disabled. It's a function which receives context as argument. Just like guards, all the actions also receive context in the first argument. And here I'm going to simply log console.log. We are in the disabled state for context.content. Okay, so if we are in the log disabled state, the moment the machine enters the disabled state, this action will execute. Let me refresh the page and see what happens. Okay, there is a console log. Okay, the log statement worked perfectly fine. So if I return something here, return null or whatever, nothing really happens. So this is simply a side effect. The return value, or the whatever we do inside this function, the machine has nothing to do with it. It simply runs the function, doesn't care about the result, does not update context, etc. But we can update context if we use a special utility inside Xstate called assign. We can use this to update the context when a state transition occurs. So let us use this logic to move the clipping logic inside the machine itself. So we'll make our machine even more intelligent. So what we'll do now is we'll move text to show into context, and we'll initialize it with content. And instead of hard coding this, instead of getting this value from the component, we'll grab it from the context. Okay. So one important thing to note here is that this argument here, where we are supplying context, so this is the initialized value of the machine. So we are passing in the initial content and initial text to show values for the machine. So the first time the machine is initialized, the context value will be taken from here. Eventually, over a period of time, even if the content changes because of props or whatever, the context will not be updated via this. The context updation can only happen inside the machine. It cannot happen from component updates. So this value is sent only once to the machine, and over a period of time, because of various state transitions and actions, the context value can change, but the change can only happen internal to the machine. The external events cannot affect the machine. Okay, so now if I want to grab the context at all times, I can grab it from inside the state object. So I can grab it like so. So const context equals state, and I can grab text to show from that as well. So const text to show is from context. Okay, because we have initialized text to show as context, as content here, all of the components are now in the so we are showing the complete text for all of our components. We don't want that. Obviously, we want our text to show to be clipped if it is in the clipped state, or the complete full version of the text if we are if we are in the unclipped state. So what we'll do now is we'll create two actions. One is called clip, and this is an assign action. So you create an action just like this action here, function that receives the context as first argument, but whatever is returned here will be the new context. So here I'll return context, all of the original values in the context, whatever they are. As of now, it's only just content, so I can simply do this. Content is context.content, and the text to show is the sliced version. We want to slice it. So context.content.slice 0 to 200. Okay, so this is simply a function that Xstate will fire and forget. It won't care about the return value unless this function is wrapped inside assign. So I'm going to put this inside assign. Just wrap it inside assign. That's it. So now whatever value is returned here will be sent to the machine as new context. I can do the same thing. I'll create another action called unclip. And here I'm going to reset it back to content. So now when the clip action fires, text to show will be updated, and unclip will again reset it back to the original content. So now it's all about using it now. So just like we have created an on entry action for disabled, I'm going to create an on entry action for clipped. So on entry, I want to clip, and on entry, I want to unclip for the unclipped state. Very simple. Okay, now I'm going to refresh the page. Okay, so now it is clipped. Now I can click on read more. The full version is visible now. Now the same thing with the last display text component. Our read more component is pretty much complete. So let us do a small recap. So we have already seen how we can create multiple states. We have seen how we can create guards and have transient states, a transient initial state, and move to a state based on a condition. And once we move to the state, we can execute actions to modify the context or to log something to the screen. So states are the mental model that you have basically as how you imagine your component to behave. So there is clipped, unclipped, two states where you display clipped or the full version of the text, and then you have transitions to move from one state to another, and then you have guards for deciding whether you want to make a transition or not, and actions are simply fire and forget functions, but there are also more powerful actions like assign actions, which you can use to update your context. So now you have a complete state machine that is capable of having multiple states, transitioning across multiple states, and also hold values and be intelligent and make decisions by itself. So that's it for this video. So we have covered the foundations of Xstate. I hope this video was useful to you, and please like and subscribe to my channel. Thank you very much.